Hey, hello everyone. So welcome to this lecture on Surds. So if you look at the learning outcomes, alright, it's very little. But the most important thing here is you need to know how to rationalize the denominator. Okay, this is a very important skill. Okay, and will definitely come out in your O-level exam. Okay, for A Math. Okay, the next one will be solving equations involving surds. This one is relatively simple, but I will illustrate this with an example later so that we'll all be on the same page. Okay, so the first thing you might ask, okay, in this lesson is what is a surd? Okay, so a surd, right, is just an irrational root of a real number. So if you recall from what you learned in Sec 1 Math, irrational means that it cannot be expressed as a fraction or decimal. Okay, that's why the example that I gave you are things like root 2, root 3, okay? Because when you type this into your calculator, you get a lot of decimal places, infinite number of decimal places, okay? And you cannot express this as a fraction at all. Okay, so it's irrational. So if you ask me, okay, things like root 4, root 9, they are not surds because you can express them as fraction or decimal. Because when you calculate root 4, you get 2, calculate root 9, you get 3. Okay, so that's what a surd is, alright? Irrational roots of real numbers. Okay, what's important here is you need to know the basic operations on surds. Okay, so in part A, you have a root A times root A. So when you have the same number multiplying to each other, okay, you represent it as a square, right? So let's say I have a root 2 multiplied by a root 2. You can write this as root 2 square, right? Then it will give you 2. So when you square a square root, you will remove the square root. Okay, part B is, let's say I have two different types of square roots, right? So let's say I have a root 2 times a root 3. You can just classify them under the same square root, 2 times 3 to give you root 6. Okay, straightforward. The next one is likewise it's like division, right? So let's say I have a root 6 over a root 2. You house them under the same square root. Okay, then this is root 3. Okay, part D looks complicated, but is essentially just factorization. Okay, m, n, and a are all numbers. So let's say I have a 2 root 3 plus or minus 6 root 3. Okay, so what you do is you just group the numbers together and then put the square root outside. So it's essentially just factorization. Okay, you factorize out the root 3. Okay, so it's nothing too complicated. Okay, what's important is the next two topics. Conjugate surds and rationalizing denominator. They go hand in hand. So what does conjugate mean? If I present you with a surd expression that is a plus, the conjugate will be minus. Okay, vice versa. If I present you with a surd expression starting with minus, the conjugate will be plus. So it's just different sign, plus and minus. Okay, so this is important, okay, for rationalizing denominator. So keep this in mind. For rationalizing denominator, why do we need to do this? Is such that we need to make the denominator a rational number. So this portion here is very important. It will definitely get tested. So I need you guys to listen up. To rationalize, okay, we are trying to make the denominator a rational number and not a surd. So what this means is that you look at part A, we start off with a root B, but in the end, it's all equal to, this, where the denominator is no longer a square root. Likewise, for part B, you see the denominator has square roots, but eventually when we rationalize it, the denominator will not have square roots anymore. So that is why we rationalize. Okay, so how do we rationalize? Okay, look at my examples here. Let's say I have a 5 over root 3. Okay, so the denominator is a surd, right? So we don't want that. So how do you get rid of it? Multiply by root 3 on top, multiply root 3 below also. We can do this because it does not change the expression. I'm just multiplying by 1. It's just another way of writing it. Okay, so this is a 5 root 3 over root 3 times root 3. You follow what you've learned in part A, you'll get 3. Okay, then you look at the next one. Okay, how do we rationalize this? Let's say I have 7 over 2 plus root 3. Okay, to rationalize, multiply by conjugate surd. See? So what's the conjugate? Just change the sign. 2 minus root 3 over 2 minus root 3. Okay, so in the numerator, you will just expand. So it's 14 minus 7 root 3. Okay, then the bottom is just 2 plus root 3 over 2 minus root 3. Agree? Then the question is, how do you expand the bottom? Okay, recall your a plus b times a minus b. Okay, equals a squared minus b squared. So you will get 14 minus 7 root 3 over 2 square minus root 3 square. So the bottom is 4 minus 3. So eventually you will just get this as your answer. Okay, so this is how you rationalize the denominator. You multiply by the conjugate surd. So you must be very clear with this. Okay, alright, last part here. Solving equations involving surds. So I'll illustrate this with an example. But do take note, I wrote here, check the roots, okay, or the solutions to see if they need to be rejected or not. Okay, so I'll illustrate this with an example to show you what I mean. Okay, so all of you write this down. Okay, this example, let's say I ask you to solve this third equation. Square root x plus 7 equals x plus 1. Now, to solve this equation, we must first get rid of the square root. In order to do that, we must square both sides. Square both sides, then the square root will disappear, right? So x plus 7 equals to x plus 1 square. Okay, then as you can see, how do we expand the one on the right? Okay, a plus b bracket square is a square plus 2ab plus b square. So I'll get x square plus 2x plus 1 equals to x plus 7. Then shift, okay, the terms, group the like terms together to get x square plus x, then minus 6 equals 0, right? Then how do we solve quadratic equation? Factorize, okay? So you factorize, you get this, right? Then by zero product rule, you get x is negative 3 or x equals 2. Now for surd equations, it's special. You need to sub back these values, these two values, to check whether they are acceptable or not. So you look at negative 3, right? If you put negative 3 back into the original, you will get, okay, you just check in your mind lah, okay, minus 3 plus 7 equals minus 3 plus 1. So is this true? Root 4 equals to negative 2. This is not true, right? Because all square roots are positive. Okay, all square roots are positive. So because you know that this is not true, okay, based on checking, you can check with your calculator definitely. Therefore, you must write over here, rejected. Okay, then you can check for x equal to also. Okay, it will be 2 plus 7 equals 2 plus 1. Square root 9 equals to 3. Yes, this is correct. So therefore, you will not write rejected for this one. So you must check, okay, whenever you solve surd equations, you must check whether they need to be rejected or not. It could be a case where both are rejected, or one is rejected, or both are accepted. Okay, so you must always check, okay, the answer when you solve for surd equations. Okay, so for this lecture, what's important here is rationalizing. Okay, so go and learn this up properly, and solving equations involving surds. Okay, and operations are quite important as well, okay, because they will merge this type of questions with your indices concepts. Okay, so just go and learn it up properly, and this will conclude my lecture on surds.